decompose a rational expression, we must first factor the denominator. I have a GCF, and then a difference of 2 squares. So in order to decompose this original, I would need to come up with 3 fractions. Each fraction has or contains one of the factors from the denominator. Doesn't matter what order you put those in, your answer will come out the same even if it's in a different order. So we're going to be solving for numerator A, numerator B, numerator C. Multiply this entire equation by the common denominator. I'm going to take this work out of the way so we have plenty of space. As I distribute from the first fraction, the entire denominator will factor, and we're just left with the numerator. By design, that should always happen. Then I need to multiply the A by x plus 2 and x minus 2. The x factor cancels. I need to multiply B by x and x minus 2. And I need to multiply C by x and x plus 2. Okay. Right here, if I were to multiply those 2 factors, I'd have x squared minus 4. Now I'm going to distribute the A, B, and C. Ax squared minus 4a plus bx squared minus 2bx plus cx squared plus 2cx. It's time to write a system of equations. We have 3 values we're looking for, 3 different numerators, a, b, and c. So we're about to write a system of equations that has 3 equations. First one will include all of the coefficients of an x squared term. First equation, 1 equals a plus b plus c. Second equation, all of the coefficients of the x terms. (12) equals negative 2b plus 2c. Third equation, all the other remaining terms. 12 equals negative 4a. Here's our system of equations. Easiest place to start solving is with this third equation. It only has one unknown, so we divide both sides by negative 4 to discover that a is negative 3. We know our first numerator. Only other equation in the system where I see an a is the top one. So I'd have to go to the top equation next, plug in a negative 3 for a, add 3 to both sides. There's not much more I can do with that. So let's bring this other equation over to join it as a system. But as I do that, I'm planning ahead, and I'm going to divide that entire equation by 2. That way, when I add the equations together, I eliminate a variable automatically. Divide by 2, and we know C, our third numerator. Only numerator we do not know is B. So we will take one of our equations. Any equation from the original list is what we usually do. So I could take any equation, plug in values. I know A is -3. I don't yet know B. I know C is 5. Pardon the writing, my smartboard's being sassy. Oops, I said I know that C is 5. I should have plugged in a 5 there. Combine like terms. Subtract 2. And now we know all three numerators. Our answer should be the three fractions, indicating addition or subtraction. A is -3. That was over x. B is -1, so I could make this a subtraction now. Over x plus 2. C is +5 over x minus 2. And again, if you wanted the practice of adding and subtracting fractions, you could get a common denominator and add those three fractions together, combine those three fractions using addition and subtraction, and you'd end up with the original rational expression.